Okay, so here is the key to your review. These first 4 questions are just simple unit circle questions. I want the sine of negative 4 pi thirds. So negative 4 pi thirds puts me in the second quadrant. Sine is positive in the second quadrant. This is a positive square root of 3 over 2. Secant is the reciprocal of cosine. Negative 7 pi sixths is in the second quadrant. So cosine is negative in the second quadrant. Cosine of pi 6 is the square root of 3 over 2, but I want the reciprocal of that, so that is 2 square root of 3 over 3. Cosine of 7 pi fourths is in the fourth quadrant. Cosine's positive in the fourth quadrant, so it's square root of 2 over 2. Cotangent of pi 6, it's in the first quadrant, so it's positive. The tangent of pi 6 is the square root of 3 over 3. The reciprocal is the square root of 3. All right, number 6. The amplitude here is 1, but there is a negative, so there's a reflection. The period is going to be 2 pi divided by 4, so it is pi halves. All right, so my sine graph looks like this. So I'm going to start here. I don't have any shifts, so 0, 0 is 0, 0. The period is pi halves, so there's the end of the period. So I have the beginning and the end. Halfway between is the middle. There's the middle of the period. Then halfway between these two, I would be at 1, but there's a reflection, so I'm at negative 1. Halfway between these two, I'm at 1. So there's my 1 period between 0 and pi halves, and then I just repeat that. So I have zeros at every intersection. And then I alternate these. And then I can draw that in. And these should be curves, not zigzags. And there are arrows on the end because it continues on. All right, number 2, amplitude. There is no amplitude. It's undefined. But I do have an A of 2 that I need to pay attention to. The period for tangent is pi, so when I divide it by 2/3, I get 3 pi halves. My tangent parent function looks like this. So I start at 0, 0. There's no translations anywhere, so I'm at 0, 0. The end of the period is 3 pi halves, so there's this point. This point here will be down here at 3 pi halves. Halfway between these two, I get an asymptote. So 1, 2, 3, 4, 5. So halfway between 0 and 3 pi halves is 3 pi fourths. So right here is my asymptote. Then halfway between this 0 and the asymptote, for my parent function, I'd be at 1. But this has an A of 2, so I go to 2. There's no reflection. Then halfway between these two, I'm at negative 2. Okay, so there's my 1 period. Then I just repeat here, here, asymptote. And then I can draw that in. And there's an asymptote there. Okay, number 7. Amplitude here is undefined again, but I do have an A of 3 halves. The period, This is secant, which is cosine, the reciprocal of cosine. And that means my period for the parent function is 2 pi. When I divide it by 8/3, I get 3 pi fourths. Okay, so I start here. This is at 0, 1. That would actually be at 0, 1.5. Then the end of the period has the same y value, so the period goes to 3 pi fourths, so I'm right here. Halfway between the two would be my minimum for cosine, so halfway between these two, I go down to negative 1.5, and I'm right here. Then halfway between these two is an asymptote, and an asymptote here. So halfway between these two, right, because this is already in the middle here, this is 1.5 spaces away. So I need to go 0.75, which is about 3/4 of the way this way. And then coming this way, I'm going to go about 3/4. And that is my one period from 0 to 3 pi fourths. So then I can repeat all of that. And get my asymptotes in there. And then get the rest drawn in. There's number 7. All right, number 8. The amplitude, again, is undefined, but I do have an A of 3 that's important to me. Cosecant is the reciprocal of sine. So the period is 2 pi, but then I divide by 2 to get pi. All right. So I start here at 0, 0, and there is no... there's no shifts, so everywhere I have a 0, these are asymptotes. So I actually have an asymptote here on the axis. That's this one. Then there's one at the end of the period. The period is pi. Then there's one halfway between, which is at pi halves. And then halfway between these two on the parent function would be at 1, but I'm actually at 3 here. So halfway between these two, I'd be at negative 3. So that's one period going from 0 to pi. Then I can just repeat. Get in my asymptotes. Points. And then draw them in. All right, number 9. Identify the amplitude, period, translations, and midline. So this is cotangent. So once again, this is undefined, but A is important to me. That is 1/2. The period doesn't change, so it's pi. I'm going to move to the right, pi, up 3. So my midline is at y equals 3. So I'm going to start by graphing my midline. And then this is cotangent. The parent function for cotangent looks like this. So I start with an asymptote. So there's an asymptote on the axis, but I have to shift to the right pi. So that first asymptote goes here. That's this one. Then the last one would be at the end of the period. The period is pi, so I go to pi, but then I have to shift to the right pi, so I end here. That's the beginning and the ending of that period. Then halfway between these two asymptotes is a 0. So remember, my midline is like my new x-axis. So halfway between these two, I have a 0. Then halfway between these two, for my parent function, I'd be at 1, but that a is 1/2. So halfway between these two, I go up 1/2. Halfway between these two, I go down 1/2. That has a period of pi. That is what I can take to repeat. So I have an asymptote every pi. I can go back and get my points in. And then sketch it in. There you go. Number 10, the amplitude is again, oh, it's not undefined. It is 5/2 here. The period is 2 pi divided by 3/2, which is 3 pi. Phase shift, I'm going to move to the left, 3 pi/4. And my vertical shift is down 1, so y equals -1. So here is my midline. Cosine, parent function, looks like this. So it starts at 0, 1. So this is my new 0. So 0, 1, but it's really 5/2, so I really go from the midline 1, 2.5. Then, okay, so here at 2.5. And then I have to do a phase shift to the left 3 pi/4, so that puts me here. And I've already taken care of the vertical shift since I used the midline. So that's the beginning of the period. The end of the period has the same y value. The period is 3 pi, so I would be way off of my graph, but then I have to move to the left 3 pi/4, and when I do that, so I'm beat out here at 3 pi, when I move to the left 3 pi/4, I end up here. Okay, so from here to here, this is 3 pi. Okay, because if I went from -pi to 2 pi, it'd be 3 pi, and it just shifts over a little bit. So that's the beginning and the end of my period. So halfway between the two, which would be at halfway between 0 and 3 pi would be 3 pi/2. So I really just need to go 3 pi/2 this way, move over a fourth, however you want to think about that, or you can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 11 pi/4 as you go around across there, so you can go to 6. 1, 2, 3, 4, 5, 6. So this is halfway, and I would go down from the midline 2.5 to right there. Okay, and then halfway between these two is a 0 and a 0. So 1, 2, 3, 4, 5 pi/4. So 1, 2, 3, right there. 1, 2, 3. Then I can just repeat that. So this would be 2 over here, and this will be down here. Then sketch that in. It is a curve. It is not a zigzag. And there's your graph. Okay. All right, number 11. I want to take the cosine inverse. So when the cosine value is the square root of 2 over 2, the angle is pi/4. When the tangent value is negative square root of 3, that's going to be a negative pi/3. It can only go from negative pi/2 to pi/2. So then I want the arcsine of the sine of pi fourths. Well, since this falls between negative pi halves and pi halves, my answer is just pi fourths. But I could work it out. I could take the sine of pi fourths, that's the square root of 2 over 2, and then the sine inverse of that gives me pi fourths right back. All right, so then the arc cosine of the cosine of 3 pi fourths. Well, this has to fit between 0 and pi, which it does. Or again, you could work it out. Cosine of 3 pi fourths is negative square root of 2 over 2, and then the cosine inverse of that would give you 3 pi fourths. So then the tangent of the tangent inverse of 3, well, I can take the tangent inverse of anything from negative infinity to infinity. So once I take the tangent inverse, then take the tangent, that's going to give me 3 right back. Cosine of the cosine inverse of 3/7, well, I can only take the cosine inverse of something between negative 1 and 1, and this fits, so that means in the end, my answer is 3/7. All right, so then the sine inverse of the cosine of pi thirds. So sine inverse, the cosine of pi thirds is 1/2. And then the sine, that when the sine value is 1/2, the angle is pi sixths. And then I want the sine of the cosine inverse of the square root of 3 over 2. So when the cosine value is the square root of 3 over 2, the angle is pi sixths, and then the cosine of pi sixths is 1/2. The arctangent of the sine of 2 pi, well, the sine of 2 pi is 0. Arctangent of 0, so when the tangent value is 0, the angle is 0. Then the cosine, the tangent inverse of the square root of 3, that's going to be pi thirds, and then the cosine of pi thirds is 1/2. The sine of the arctangent of negative 24 over 7. All right, so I don't know what that value is, and these definitely don't cancel each other out, so I have to draw myself a picture. So when tangent is negative, I'm using quadrant 4. This is my angle. Tangent is opposite over adjacent, so this is 24 and this is 7. So that makes that negative there. So then you can do Pythagorean theorem or know that it's a triple. That makes this 25. So then the sine of that angle, whatever it is opposite over hypotenuse, which is negative 24 over 25. All right, so then I have to draw a triangle for this one also. This cosine is negative, so then that means I'm in the second quadrant. Cosine is adjacent over hypotenuse, so this is 3 square root of 5, and this is 11. We'll make that negative there. Then I do Pythagorean theorem, because this is definitely not a Pythagorean triple. When you do that, you're going to get 2 square root of 19. Then you're going to take the tangent of that angle, and tangent is opposite over adjacent, so it's going to be 2 square root of 19 over that negative 3 square root of 5. Then you have to rationalize. Once you rationalize, you get negative 2 square root of 95 over 15. Okay. The key to the optional graphing part will be in the resource folder in Google Classroom.